Okay. Never done this before, never streamed before, but I'm going to try to learn to make a game. This is really awkward. It's going to be super cringe at first while I am not talking to anyone, and I don't know. I'm just documenting me learning something, I suppose. I downloaded a game engine called Godot, and I've started a new project. And truthfully, I have had a little look at this, and I imported some 3D assets into another project. But that's it. But I'm going to learn from the beginning how to make a game. Now, I had an idea for a game that is like a basketball game, but a platformer where you're just bouncing. You have to keep the ball bouncing through obstacles. And there's a nice city background, and there's like physics with the ball. And I just thought, and you can throw it in, a net will come by every now and again. You can throw it in there for points. And then I thought, I'll just start by making a controllable bouncing ball with a 3D city in the background along a 2D plane. So that's what I'm going to try. And I'm going to be learning and watching the videos. Never done anything like this before. So I'll just see how I go. Great.
They're coming straight in. Trust me, I've got nothing.
This project is from the ground up for absolute beginners, so we will start by installing my game engine of choice, Godot Engine.
Yeah.
Find your way to godotengine.org and click download later.
Okay,
Now we are in the
create
game
a 3D
engine
scene.
proper, we can get our starting 3D scene set up. We need three things to be able to see our game world in action: a camera, a world environment, and a light source. Create a new 3D scene by selecting the 3D scene option from the scene tree dock.
I have that.
This node 3D is the root of our scene, and we can add more nodes as children of it. Click the plus icon at the top of the screen to create a new node.
Let's do that. Let's start with this. Let's start a 3D scene. Okay.
Or use the shortcut Ctrl and A. Type Camera 3D into the search bar at the top of the Create New Node window.
Camera 3D.
And click on the Camera 3D node from the list below and click the Create button to add this new Camera 3D to our scene. This camera allows us to see the game world when we run the game, but at the moment there is nothing in it to display, so we need to add a world environment and a light. At the top of the viewport there is a toolbar with buttons for previewing our game world. Select the button with 3 vertical dots. This opens a menu for adding preview environments to the scene. Click the Add Sun to Scene and Add Environment to Scene buttons to add the...
That's probably what I was missing from my little walk around. I did notice there's some controls here. If I hold down the middle mouse button, I can sort of rotate, pivot stuff around. If I hold down the right mouse button, I can move around with WASD like in a game. So that's a useful way to get a bit closer or further away to things. So that's my camera. He was just saying to add a sun. Don't know if that did it. Okay. And I did work out this much. Okay, that's moving the camera. I'll undo that. I will pick up the sun, make it higher. Seems like it should be higher. And looks like it's pointing that way, so I'm going to rotate it to point sort of in front of there. I'm just looking. I don't know how people would see me on Twitch, or if this is even doing anything. me see. And really, I don't care so much if people are watching me or not. I'd prefer I wasn't watched. This is sort of me trying
there's no music
to
for this thing?
just
Oh, boo.
document my experience learning something. Let me just see what's going on. It says I'm live. Let me just see what's going on. Yeah. It says I'm live. There I am chatting away. That's fine. Okay, well I've got the chat room open now and I'd be able to see if anyone was watching me. And it's me watching me. There's one person. In OBS, there was I've got a little bit of streaming experience, enough that I know my way around OBS a little bit. But there was like a stream, like a chat thing for Twitch, which I can't find now. View. Doesn't matter. I'll try and keep an eye on it. Okay. So I've pointed the sun in a direction that I think is right. Let's go back to the video.
Default world environment and directional light 3D to the scene. You can customize colors and light angles with the options in this menu.
Okay. Add environment scene. Ground color. I'm going to make this a bit of a lighter grey. Forget it. Forget it. That'll do. Okay. All right.
Now we can get our scene running in real time. In the top bar on the far right, you will see 6 buttons that are all playback controls. Click the Run Current Scene button, which looks like a play button on a clipboard. Godot will then prompt you to
Let's see if he decides.
save the scene if you haven't already. I will name the scene level.scene in the file prompt at the bottom and click Save.
Level. Let's do it. Level. Oh, okay. Level. Okay. Look. A 3D world. That's cool. All right.
A window will open with our game running, and this will look like the viewport in the Godot editor itself, just showing the procedural sky we added in our world environment as viewed from the perspective of this new camera. Now is a good time to add a floor to give us something to look at, and get used to orienting objects like the camera.
Okay,
To act as a floor, we need to add a mesh instance 3D to our scene.
Mesh instance.
When you add a node to the scene, it is added as a child of whatever node is selected in the scene tree.
I've got
Left
some
click on the node
textures.
3D.
I have some textures and cityscape 3D models that I downloaded.
To select it. Selected nodes are highlighted with a pale blue rectangle.
Okay.
With the node 3D selected, open the Create New Node dialog. As you might be able to remember, we can either use the plus or we can use the shortcut Control and A. In the search bar, find and select Mesh Instance 3D, then click Create.
Mesh instance 3D. I double clicked it.
This Mesh Instance 3D node is our essential tool for showing simple 3D shapes. In the scene tree on the left, you should see the mesh instance is now selected with the light blue highlight. If not, select the Mesh Instance 3D by left-clicking on it. When a node is selected in the scene tree, we can access their properties in the inspector on the right. In the inspector, the Mesh Instance 3D node has a mesh property, where we can select how it should look from a variety of primitive shapes, like box, sphere, and cylinder. To select a mesh for this Mesh Instance 3D, click on the word empty next to the word mesh. Then select New Plane Mesh from this list to create our floor mesh.
Selected mesh, new plane mesh. Okay, it's going exactly like the video.
This plane is then visible in the editor's viewport as a 2 meter by 2 meter grey square. The plane is only visible from above, as a plane mesh is a one-sided object.
True.
If you move the mouse over the viewport, you can control the view with a variety of gestures. Click and hold the middle mouse button and drag the mouse up, and your view will rotate down to a view below the floor, showing it is transparent from the other side. Click and hold the middle mouse button and drag the mouse down to rotate the view back up, and you can see the floor again. The floor is too small at the moment, so we're going to need to update its size in the inspector. The mesh property of the Mesh Instance 3D now holds a plane mesh object that we can customize. If you click on the picture of a plane, the object will expand and we can customize its properties in the inspector. Godot has objects we can expand like this, as not all meshes will have the same properties. This plane mesh only has a width and a height, but if we say had a box mesh, it would also have a depth property.
Makes sense.
We can set the floor's size with the mesh's size property. Set the size property's x and y values to 10 meters by 10 meters. You will see the mesh updates in real time in the viewport. While hovering the mouse over the viewport, you can scroll the mouse wheel up and down to zoom the camera in and out for a better view. Now,
I was going to deviate from the instruction, but I've decided not to. I'll keep going. I was going to move on to make my platformer. Will I? No, I'm going to keep going.
now we need to move our camera 3D node for a better view. If we run the scene as it is, we will not be able to see anything because the camera is inside the floor. If you ever quickly want to check what the camera 3D can see, select the camera in the scene tree and hit Ctrl-P to toggle the camera preview. This will show what the camera can see directly in the viewport.
Oh,
You can
great tip. Control P. This is the viewport. Okay.
also toggle this view with the preview check mark in the top left of the viewport. To update the camera's position and orientation, we can use the 3D Gizmo. This is a handy tool available directly in the viewport for whatever node we have selected in the scene tree.
Got it.
Select the camera 3D node in the scene tree so we can update it with the gizmo. The gizmo is the 3 arrows and circular arcs in green, blue and red in the viewport. The gizmo is centered on our camera, which is made visible as a small purple pyramid with a square base indicating the direction the camera is pointing. If you hover your mouse over the tips of the arrow on the gizmo, the arrow will change to white. This indicates you can drag the whole node in that direction by clicking the left mouse button and dragging. The motion is locked in the axis of the arrow. Click the green arrow and drag the camera upwards. If anything happens you don't expect, the editor supports using Ctrl-Z and Ctrl-Shift-Z to undo and redo actions.
Let's do it. Up we go. Now let's do preview again. There's the floor. It's there. Do it. Skipping ahead.
We can now use that preview toggle to see what's
Skip it
green.
a little bit.
This gizmo updates the position values manually in the form drop-down. You should see the position's Y property is something other than 0 as you changed its position with the gizmo. I will manually set the camera's height to 2 meters up by selecting the Y value in the position property and entering 2. Now when running,
Yeah, that makes sense as well. That's really high. Okay.
in the current scene with F6 or the play current scene button, you should see the same thing I do here.
Yeah, I kind of know that I
Godot offers many powerful graphical options to control the appearance of what you create. You encounter, and from that drop-down list, click on Full Options. On the left, drop down, click on the Window button, and options relating to your game window will open on the right side of the page. I'm going to set my viewport width and heights to the same dimensions. I also want my game to take up the full screen and leave the mouse free to close the window, so I'm going to change the mode to maximized.
Okay. I'll do that too, because I do want to make the game 1080 by 1920. So that's in display, viewport width, 1920, 1080, full screen, initial position center of primary screen. Yeah, sure. So let's try that. Oh my god, it's used the whole screen. That's not 1920 by 1080. F6. Okay, F4. I'll need it to be windowed then, won't I? Maximized. Okay, that's what he said. Okay. I could just go windowed for this because I have an ultra wide monitor, and so I've actually just got a small section of the screen displaying. So I'm going to just make it windowed. For me, I'll just test one more time. That's great. That's what I wanted. So you guys can't quite see you guys. There's no one watching. Someone's calling me. I just have to leave that. I decided to just give this stream like 45 minutes to an hour and then stop. Let's carry on.
The stretch mode and resizable options on the screen are often important in letting you make the screen have fixed dimensions and stretching pixels to keep the viewport scale the same on different monitors. The next important setting to cover is anti-aliasing options. Under the rendering subheading, you can find and select the anti-aliasing tab. Anti-aliasing options help us avoid jagged, sharp contrast edges in our games. These options are all disabled by default for the best performance. Hovering over the names of options like MSA 3D will reveal a tooltip giving you more detail about the option. I'm going to set the multi-sample anti-aliasing MSAA 3D to 2 times.
Yeah, the dog's
To keep this window streamlined, Godot 4 added an advanced settings toggle in the top right.
okay.
Clicking on this toggle will reveal many more project settings that are worth scrolling through and investigating at your own leisure. Rendering drop-down. About the directional shadow section, as that covers the sun we added earlier, and we don't have any other lights. Click on the drop-down for soft shadow filter quality and you'll see a whole host of options. I will slightly improve the quality by changing the quality to soft medium.
Where was he? Lights and shadows. Rendering lights and shadows. Lights and shadows. Soft medium. Under directional shadow.
Medium.
Sure.
We are now 1/3 of the way through my guide on how to create a 3D platformer in Godot 4.1. This is all part of the free supplement in my course Godot for Beginners. If you head on over to itch, there's a link down there, you will be able to go ahead and download these 3 sections all in written form so that you can follow. That's all covered as beginners. Have fun. Character up and running. We may want to add the player to a variety of levels like this. Click the scene drop-down and select New Scene. In the new window in the scene tree, select the Other Node option, and lets us select any in the scene tree, scene drop-down, and select New Scene.
Okay.
In the new window in the scene tree, select the Other Node option. When you select the Other Node option, the Create New Node dialog opens and lets us select any node to be the root of our scene. For our player character, 2 nodes are up for consideration: Rigid Body 3D and Character Body 3D. I am going to show you how to make a Rigid Body 3D player character. This is physics-based at the cost of less precise control than the kinematic counterpart.
That's my basketball.
In the search bar, find Rigid Body 3D, select it, and click Create.
Okay. Scene, new scene. Other node. Rigid Body 3D. Yeah. I'm going to call it ball.
Now we can see our Rigid Body 3D in the scene tree. Double-click on the node and rename it to Player, then hit Enter.
Oh yeah, player would be better. Just checking that message. Yep, that can just be a callback for later.
When you create a body node in Godot, to make them interact with other nodes and the physics of the engine, we need 2 things: a mesh, so we can see the body, and a collision shape 3D. Add a mesh instance 3D as a child of the Rigid Body 3D we named Player. This node is how we will see our player.
Okay, add a child node. Mesh. Instance 3D. Okay.
With the Mesh Instance 3D selected in the scene tree, look to the inspector on the right. Click the Mesh property drop-down and select New Capsule Mesh from the list.
I'm going to do a sphere. I am going to deviate. New sphere mesh. I get it now.
When you have a Mesh Instance 3D, you often will want to create a matching collision shape. To help with this, there is a contextual mesh drop-down at the top of the viewport we can use to generate a collision shape 3D.
Okay.
With the Mesh Instance 3D selected, click the Mesh button at the top middle of the viewport. Then, from the drop-down, select Create Simplified Convex Collision Sibling. Now we have our collision shape, we can
Create simplified convex collision sibling.
focus on setting up our Rigid Body 3D for use as a player character. Select the Rigid Body 3D player.
What I'm doing, I have an Explorer window off to the left. I'm going to import the art that I had before because I downloaded a basketball 3D image and I downloaded the cityscapes that I mentioned earlier. And I think that I can do a surface material override or something. I can apply the skin of the basketball to this character. And so I'm just going to copy the art folder, essentially, that I had before, and it will pop up in here. Was it objects? Oh, okay. Basketball. Oh, yeah. I might just be able to copy the basketball part only. New game 2. I'm going to call it assets basketball. Then this will refresh. I got something in the chat from a bot. Yeah, no thanks. Okay, so let me see. Visibility. I feel like I can work this one out on my own. Geometry, yeah, okay, that's the shape. Okay, surface material. Load. Let me try it. Textures, no. Source. Oh, I thought that it might. Let me check my original download of that basketball. That might show me something more that I didn't know of before. Objects. What's it looking for? Trez dot material dot res. Source. Oh, dot MTL. That seems like material. What is dot MTL? Wavefront material. Seems like it's the right thing, but it's not compatible. But I do have like a JPEG. I'll show you. See this? Like it could just wrap it. It could just wrap the 3D object in this and it has that material for the lighting stuff. But maybe I can't work it out because I'm...
In the scene tree and in the inspector, find the lock rotation property and enable it. Rigid bodies are often used as physics objects, with great freedom of movement and rotation. We need to lock our player's rotation so the capsule does not tip over as our player walks around. Godot uses script files to give instructions for use as a player character.
I don't have a camera on that player.
Select the Rigid Body 3D player in the scene tree, and in the inspector, find the lock rotation property and enable it. Rigid bodies are often used as physics objects, with great freedom of movement and rotation. We need to lock our player's rotation so the capsule does not tip over as our player walks around.
I get it.
Godot uses script files to give instructions to the objects in our games.
Okay.
We write these in the GD script language, a specialized lightweight scripting language. We will add a script to our player character that will listen to key presses and use those to move the player in the corresponding direction. Right-click on the Rigid Body 3D root of our scene, and from the drop-down menu, select the Attach Script option, which is an icon of a little scroll of paper and a green plus. This will open a contextual window for creating a script file. We do not need to customize any of these options, so just click Create.
Cool. I'm with
This will change our main screen for the first time. Instead of seeing the 3D viewport as usual, we can now see the script screen. You can swap back and forth between these screens by clicking on the 3D button or the script button in the middle of the top bar as you need them. Our script has a few lines that are important to us right now. The first lines of the script says extend, then the name of the node, in our case, extends rigid body 3D. This tells us the script is attached to a rigid body 3D node, and we can access all the properties and functions of a rigid body 3D in code.
Okay.
2 functions have been added to this script by default. The functions are defined with the keyword func, followed by their names and parentheses.
Funk. I like it.
We will be focusing on the process virtual function. Godot has a bunch of virtual functions. A virtual function is a kind of built-in function you can add for a specific task. They have a specific name and specific parameters.
Okay.
Process is a virtual function. It runs every frame, so usually 60 times per second. This makes it an effective way to update your game in real time. The delta parameter tells us how many seconds it has been since the last frame, which is necessary for making changes appear the same on different machines, no matter how fast the game is. Separate code it is in want to pass is often used inwards. Input is a global script arrow length function gives us a value of 1.0. Otherwise, it returns 0.0 and the player will not move. 3D, it's 3D directions are represented by the vector pointing forwards. The asterisk symbol means player will move, multiply will give us no when the button or 0.0 if it isn't. Apply central force is a function of the rigid body 3D itself. It lets us apply a force in a 3D direction. 3D directions are represented by the vector3 object, and vector3.forward gives us a vector3 pointing forwards. The asterisk symbol means we are multiplying the velocity by the 1200.0 that comes after.
I get that.
This makes the force we apply larger, so the player will multiply. When the button is not pressed, multiplying the direction by 0.0 will give us no velocity. This force applies every frame, and combined with the mass of our rigid body 3D, gives us a forward velocity when the up arrow is held. Save scene as prompt should automatically name the file what our root node is called.
Okay. Do I need to write all of that in there? No, because I can do this. I think I can work out how to make those changes that I might need after saving it.
as prompt should automatically name the file what our root node is called.
Yep.
This player is now a scene we can see down in the scene tree. Double-click on level.scene in the scene tree to reopen that. Scene. Then, in the top bar, click the 3D main screen button to return our view to 3D.
Got it.
Now
Did it.
we can add the player scene to the level.
Add the scene into the scene.
Click on the root of the level scene in the scene tree to select it. Right-click on player.scene down in the file system and select Instantiate from the drop-down menu.
Whoa. Okay, that would not have been intuitive. That's probably where I was going to get stuck. Oh look, there's my my thing. I'm jumping ahead. Let's see what happens. Oh. Popped in behind. Oh, it's crashing. Oh my god. Did it? No, we're good. Let me save it. Shift P. Camera. Okay. Run current scene. Oh, it doesn't like it. It's stuck behind. Yeah, this is crashing. Okay, I don't need to deal with crashes at the moment. Let's not worry about
Instantiating a scene creates a copy of that scene as a child of the currently selected node. Now the player will be visible in the level, but there are a few things we need to clean up before we can start running the scene.
yeah.
First, our player is clipping through the floor in the middle of the viewport. This makes sense, as the player's center is in the middle of their Mesh Instance 3 node, and in the inspector, find the transform section and expand it. Set the position's Y value to 2 to raise the player above the floor, and the Z value to -2, so the player is in front of the camera.
Okay. Transform to -2. Yeah, nice.
If we run the scene now, our player will fall straight through the floor. This is because our floor is just a mesh and not a physics body like the player. In the level scene, select the floor Mesh Instance 3D, then at the top of the viewport, click the Mesh Context button and select Create Trimesh Static Body.
This is going to crash. I'll press
From the
on.
drop-down menu.
I'm not confident about this.
This creates a static body 3D as a child of the mesh instance 3D, with a collision shape matching the mesh itself. A static body 3D is another kind of physics body Godot uses that is intended for objects that do not move. Now, if we run the scene with the Play Current Scene button in the top bar, when the game runs, the player will fall to the floor and stay there. If we push the up arrow on the keyboard, the player should then hurl themselves off of the platform. Most
Okay. Maybe it's this script. Maybe it's my script. What if I did play? Oh. Oh, I don't like how it's going to crash. I'll just give it a minute to load. Not that that's going to be very interesting for the stream. If I touch it, yeah. No, we can't be having this. Okay. I'm going to go back and do better on that script. Funk ready void. Oh yeah, they think it's a V. Extends rigid body 3D. That's a comment. Colon pass replace with function body. Okay, funk underscore ready. That's good. Pass, this needs to be tabbed in. It's good. Funk underscore process delta float. Input var input. I do the built-in Windows text copy thing. This one needs to be tabbed in. Oops. You can, with Power Toys, you can copy text from images, and it doesn't work great. Var input equals input dot get action strength. Get action strength. UI up. But sometimes copying the text from an image saves a little bit of time, not much time this time. Then apply central force. Apply central force, yeah, it knows it. Input times vector 3. Vector 3 dot forward. Oh yeah, this would have been easier. Times 1200.0 times delta.
Force we apply larger, so the player will move further forwards when the button is pressed. We need to multiply the force by delta to avoid issues on machines with different frame rates. When the button is not pressed, multiplying the direction by 0.0 will give us no velocity. This force applies every frame, and combined with the mass of our rigid body 3D, gives us a forward velocity when the up arrow is held. To test this script, we need to save the scene.
Let's save it. Let's go to 3D level. Oh yeah. It's kind of moving like a basketball. That is cool. Snap that back. Let me move the camera just to tilt down a little bit. Move back a bit. I'm going to restart. Cool. Then I tap up and I'm actually making it move. Absolutely unheard of before. Tapping other buttons does nothing. I've probably only got 10 minutes left that I'm going to give this. But like, I really want to keep working on it, like even when I'm not streaming. I want to just, like when I mucked around and I built the 3D models with the basketball, I think I understand now that I needed to have mesh there to stop them falling through each other.
In the top bar,
Carry on. I can get
scene
forward this again.
Select currently, but there makes
Yeah, he's not. He's
in the top of the viewport. Click the Mesh context menu.
Yeah.
Godot
Floor.
now. When the game up arrow, use arrow keys for movement. Instead, opting for the WAF for the input the user makes. But for convenience, multiple input device support inputs trigger controllers, trigger project settings window, up event. We click the Show Built-in Actions toggle to see all the predefined actions you can listen to.
Yeah.
In the Add New Action bar at the top, type move_forward and hit Enter, or click the Add button. This creates an... On the right of the Move Forward Input event, click the plus button to open the event configuration window. Drop-down menu if you push it detected a physical key press, and now whenever we can look up by name. The Move Forward event will
Input is actually just pressed.
trigger, which we can look up by name. Repeat the process for move left with the A key, move right with the D key, and move back with the S key. You can now close the project settings window and return to the script screen. In our process function, we now want our script to listen to all 4 inputs instead of the following: the 3 up and down on the y-axis, forward and back on the z-axis. Adding movement like this is a common task in Godot, so there is a helpful function built in, the getAxis function. This function returns -1.0 if the first input event is detected, 1.0 if the second input event is detected, and 0.0 if neither or both events are detected. So, for the line input.x equals input.getAxis move left, move right, this code sets the x value of our 3D vector to 1.0 when we press the D key, or -1.0 we press the A key, otherwise leaving it at 0.0 if neither or both are pressed. After we get both of those axes, we are left with a vector 3 that can move our player in 3D space when they push the W, A, S, or D keys. Running the level scene now will let you move the player around the keys.
Let's try that. Let's try and grab this text. Script. Oh. I'm just moving it off to the left so I can see. And I'll just input is
Running the level scene now,
process float void input equals, okay, colon equals input this one is vector 3 dot 0 input dot x equals input dot getAxis. Oh, okay. I didn't do any of those things. Project settings, input map. Move. Up. Okay. Add new action. Move up. Move left. Move right. Move up. Move down. Add an input. A. Okay. cameras. Okay. Input X is move. Yeah, there they are. I'm just going to finish these and then I'll stop the stream. Move right. Input Z equals input with a capital I. Input dot get axis. Move. I called it up, but I needed to call it forward. Move down. I could do it on Y then, couldn't I? Y. Save. Save. 3D. Saving it. Script. Okay, I'm trying it with the Z then. Oh. The left and rights aren't doing anything. It's weird though. What's going on there? And does it bounce? No. Okay, I want to make it bounce. I need to fix the left and the right, forward and back, and it's not falling through. I'm going to spin up my other project next time because I started building the cityscape and the ball and the base. But I think I can take what I've learned here and put it back into the other game. So I'm gonna do that because I have a nicely wrapped ball. Oh, maybe it's easier to put the buildings in here. I think that'll be easier. But I'm gonna stop the stream now. I feel like I learned a lot, and it was fun anyway. But I'll try again next time. Okay, stopping the stream now, and I'll put this on YouTube as well, just so I can look back at it one day.